All right, let's go ahead and get started. How are you all doing today? Hi, everybody. I forgot to put that slide up because I picked up where we left off. I see there is still a lot of you here. I just wanted to check and make sure. On the first day of class, I warned you this was a hard class, right? Did I warn you there's going to be a lot of work? And you're still here? All right, just checking. Before we pick up where we left off last time, I would like to ask, are there any questions? Sir, in the corner. Yep. Yes. That's normal. No, that's fine. So the question was, in the video I show you working with two separate windows, doing editing one and doing the compiling in the other, because it's easier that way. I think in the video when I was doing that on a PC. Did I shoot that one on a PC? On the PC software that connects from your computer to the CS class remote server, there's one button you click and it gives you a second window. If you're on a Mac and you open another terminal window, you will have to go through the login procedure again in that second window to log into CS class. That's normal. Yes? Hmm. So when you look at the videos and you log in, your screen may not look exactly like mine. And the reason is because I'm a giant computer geek and I've been doing this for years. And the Unix terminal, the Unix program that we're using, Linux, allows you to customize what shows up on your screen. And I have customized my screen in a way that you probably haven't. So things like slashes will show up, a little star, stuff like that. That isn't really terribly important. Other questions? Yes? How do you open the file to type in, like using Nano? You just type Nano and then the file name you want to work with? Yep, in the terminal. Yeah. So I'm going to do some of this today. Normally what would have happened if we hadn't had a snow day on Tuesday, y'all took advantage of it, right? How many of y'all went sledding? What were y'all doing? Snow football. All right, that's snow football is also an acceptable answer. So, hey, yeah, I mean we can get through the class. It's just that I have to turn out all these lights and then all the students go to sleep. So okay. Um, anyway, so you had your snow day. Normally, what we would have done on the snow day is we would have done what we do today. And today, I'm going to go through all the steps that you would have had to do for your homework. So I gave you the extra day on your homework so that if you didn't see it today, you could do it. You can also go. How many of y'all have figured out how to find a TA? Anybody? Nobody? Okay, well, that's clearly my fault. If you all don't know something as a group, it's my fault. If some of you know it and some of you don't, then it's your fault. So I'm going to take that one. Here's how you find the TAs. You go onto Blackboard, you click Calendar over on the left, and a calendar will pop up. The calendar shows for every day who the TA is and where they are. Okay? So if you go onto Blackboard, click Calendar, you will find thing. To find the room where the TAs are located, where they will be sitting, you go to St. Mary's Hall. You go up to the 3rd floor. The building is shaped like an eye. There's 2 little stems and a long piece in the middle. The TA room is about halfway down the long stem in the middle. There's 2 receptionist desks, and right across from the receptionist desk, there's a room. It's windowless. It's full of people who are typing on their laptop and looking very stressed and worried. If you see that room, that is the TA room. And you can just walk in and go, help! And people will look at you funny, and then you just say, hey, who's the 051 TA? And whoever's in general, they'll always be there, yeah. Now, if the TAs end up having to cancel their office hours, they should change it on the calendar and also put an announcement on the front page of Blackboard, so just take a quick look at Blackboard before you go over there. Okay. So, but the TAs are there to help you. They're there to help you solve your problems. Okay. Other questions? Going. Nothing? All right. So what we're going to do is we're going to pick up where we were last time. And anybody remember what we were doing last time? Does everybody willing to remember but not willing to talk? So I actually have a bag of candy today. and I'm going to be throwing out pieces of candy to people who are, participating and answering questions. Sadly, all I have is this really weak bag of caramels because we forgot to go to Costco and get the giant candy bag, which I will do this weekend, but I still have caramels. Who would like a caramel? Anyone else? Oh, sorry, bad throw. Okay, so this will actually hopefully work over a long period of time. So who remembers what we were doing last time? Yes. We learned how computers work, and then we started into... Exactly, we had an algorithm and we gave an intro into C++ coding. And so let's just go back and quickly go through what we did before to make sure we end up in the same spot. I gave you this example program. This program implements an algorithm. What is an algorithm? A series of ordered steps that are used to accomplish a task, right? And a program is? Who wants to answer my question? What's a program? You already had one. Yes? Yes, an algorithm that can be understood by humans and executed by a computer. So here is our algorithm in C++ form. What does this algorithm do? Yes? Allows the user to input a number, then determines whether it's even or odd. Would you like a caramel? You keep declining, so. All right, so here we are. We have our thing. So if we step through this, I'm going to go through quickly what we started before. We can see some of the pieces of the algorithm and what they correspond to in our flowchart and our outline language. So the first part, here's our algorithm. It's that dark red. It says start. And the start portion of our program will generally always look like this. Pound include iostream using namespace standard int main. Okay? Do you all want to know what those mean? Who wants to know what those mean? Too bad. Okay. That means start. We'll talk in more detail about this stuff later. So here's start. When you see this, you have start. What is stop? Anybody remember what stop is? Return 0. Okay, so when we have stop, the very stop, which is hard to see on this projector, it is return 0. So stop is return 0, which gives us the shortest possible C++ program, which does what? Nothing. And what does that look like? Start and stop glued together. Okay? Every program you write during the semester will in part be this program. You will always have a start, you always have a stop. You're just going to stick some stuff right here in between to make it do other things as well. Okay? All right. Input, we were talking about input. Input is useful because it allows humans to use the program, tell me a number. And what we talked about was before you can do input, you have to tell the computer and the compiler what memory you're going to be using. You have to declare variables, which tells the computer how we're using memory, and it tells it to pick a spot in RAM to store a value. Now, this is always going to be a name, which is the variable name, a type, which tells the computer how to interpret the string of 1s and 0s, and a value if you want to set the value initially. So here we did int input equals 0, int remainder equals 0. I told you int stores what? Integers. And what are integers? Numbers that have like a decimal or a fraction, right? No, exactly the opposite. Integers only have a whole number. All right, why do we have a type? And because everything is just a lot of 1s and 0s. And depending on how we interpret those 1s and 0s matters. Because we don't only ever have numbers, we have other things like floating point numbers, characters, and true or false values. And we'll talk a lot more about types as we go along. But remember, in a computer, everything is 1s and 0s. It's stored in a box in memory. And the interpretation of those 1s and 0s is important. All right, so back to input. We had this thing cin, which we will talk about again in more detail in the future, that allows us to read a number. This is the equivalent of the input. And I believe this is where we stopped. Is it? Okay, so what cin does is it lets you ask the user for something, and when they bang on the keyboard, like the great big monkeys that we are, the data that is banged onto the keyboard will be stored somewhere. Where is it stored? In RAM. In which particular part of RAM? The what? And how are we telling it to store it? Input, right? We gave it, earlier we declared a variable. We said, hey, here's a box to store something in. And when I say input, think of this box. Use this box. And so when we do cin into input, whatever number we type in will essentially be put into that box, okay? So we've input something. Now we're going to do a calculation step. And we're going to divide a number by 2. Well, this is pretty simple, okay? What we're going to see throughout time over and over again is that anytime you want to change a value that's stored in RAM, you want to change a value that's stored in a variable, you're going to use the equal sign. That's one of two or three ways that we're going to see over the semester to change the value that's inside a box. In memory is to use the equal sign. Another one is to use this angle sign for input, and that changes it. And what do we change it to? We say we're changing it to input %2. When the computer sees that input, what does it think of? That box. It goes, okay, I've got to go to input and figure out what number is in there. Now you and I standing here right now don't know what number is in there because it's going to change every time the program runs because us giant unpredictable humans will type different things at different times. But what we know is it's going to look in this box, it's going to take some value out, and it's going to figure out the remainder when divided by 2. Okay, this % sign is essentially, it's called mod, the mod operation, and mod tells you the remainder when you divide 2 integers. We'll see how to divide and do other stuff as well. Okay, so this is equivalent of one of our calculate boxes. And we're going to come up with a bunch of different types of calculations that we can do over the course of the semester. All right. Questions so far? Yes, sir. We will talk about that later. And the reason is that when you declare a variable, it's best to initialize it to a particular value. And the reason is because what will happen otherwise is the computer will say, okay, you can have this box to store your data in. And if you don't set it to anything, it just gives you a random box that already has something in it. And what's in that box it gives you? Do you know? Nobody knows. It's not random. I mean, I've been doing this for a long time, so I have some idea what's in that box, but I would never expect you all to do it. So when you declare a variable, we'll see this again later, when you declare a variable, it's best if you set it to something that you know so that you're not subject to the whim of the computer just putting random data in your box. Does that make sense? Just the way it works. Yes, sir. Yep. I am creating a variable named remainder. We did it right up here, int remainder. We declared it. So now when we do this operation, remainder equals input, the computer will look and goes, okay, I need to assign remainder to something. I don't know what yet. So I'll get the value out of input. I will mod it by 2 and figure out the remainder. And once I've done the stuff on the right-hand side of the equal sign, I will take that result and I will stick it in the box named remainder. Yes, ma'am. Okay, so we'll talk about that a little bit. So that comes down to programming style. I'll be honest with you, I could take every single space out of this program and the computer would run it just fine. The computer is just a dumb, stupid calculating machine that does not care. Who cares? People, right? When we read our code, we have to do that. So we're going to talk a bit how to format our code. And we'll talk a bit about that. There's a couple of ways you can do it. You can either format it by hand if you're using Nano. You can run a program that automatically formats your code for you, which I can show you how to do. Or later in the semester, or as soon as you get sick of the incredible limited things that Nano allows you to do, you can switch to a better editor. All right. Now the reason I started you on the Nano editor is because it's simple and because there's so much stuff at the beginning of the semester. I don't want to break your will to live until after the add drop deadline. So, you know, I want to give it to you simple. Now, as you go along, you can use other things, and I'll be happy to show you, or the TAs will show you how to use more powerful tools. But this is just something simple to get you started. Okay, so this is how we do calculations. The right-hand side of the equal sign does some calculation. If there is an equal sign on the left-hand side, then the result of that calculation is stored away in memory for us to use at a different time. All right, and now it's time for us to use the thing that we decide. We're going to make some decision. We're going to make a decision based on something. And in this, we are going to use if. If is one of the ways that we make a decision. Okay, we're going to decide. And what if does is if looks at it and says, if the thing inside the parentheses is true, we'll do the first thing, else we'll do the other thing. Okay. Now, if we see remainder equals 0 here, notice there are two equal signs. What does one equal sign do? It changes something in memory, okay? Two equal signs is the operator that means, are these two things equal? So one equal sign is assignment, and two equal signs is comparison. A super common bug and mistake people will make when they're coding is to put one equal sign inside there, and bad things happen. Okay, bad things. And I'll show you some ways around that later because it's a little bit problematic. Okay. Whoa, sorry, I turned up the gain to make sure the recording was getting good. Okay. All right, so here we are. We have our if statement. If the first thing is true, it does this line. Otherwise, it does the other line. And if you remember, we had this decision box, right? It was like a flow chart. We could go one way or the other, and that's how we indicate that. And we're going to go into more detail about each of these things as we go along. Okay, so, and we have this thing. If so, we output odd. Otherwise, we output even. So we have output. And this is really the last piece we have is how to do output. Well, we have C in, which is input. So we have C what? Out for output. And they are related, and we'll show you how to use those. Yes, sir? Okay, we'll talk about that as well. But in general, what will happen is C out will output whatever you say, and the end L is like the equivalent of hitting the return at the end of the line. So it tells anytime you print things, start on the next line instead of continuing on the same line. And we'll get examples of that as we go on. Yes? Like this one and that one. The ones where the point is to the right are used for input, and the ones that are to the left are used for output. And we'll talk about these more. I'll just give you a preview of coming attractions. The way I think about these things is like a giant funnel. And what's happening is CN is stuffing things into a funnel, and when it comes out the other end of the funnel, it's in input. Okay? For C out, what's happening is the funnel is going the other way. The text and everything is getting stuffed into C out, which is the screen. That's I literally think about that when I'm programming. So. All right, it shows you how smart computer science professors are, right? We need these simplifications. All right, so that's how we do a program. Yes? It's ENDL, that's the letter L. Yeah. Yeah, end line, essentially. All right, so that's our program, okay? And that's stepping through our very first C++ program. Okay. Any questions on that? Oh, I forgot this part, output. All right, any questions on that so far? Yeah. How do you do what? It's just a normal L. It's just that typeface makes it look funny. So it's ENDL. The end is ENDL. It's not 1. Other questions? Yes, sir. Yeah. So here's the thing that we're going to come back to in this class over and over again, is that computers are awesome, and people range on a scale that runs from imperfect to suck, okay? People are in there. Anytime we're doing something in our program where we have to deal with people, it's going to cause headaches for us, because we're going to have to make sure when they input something, it's something that made sense, right? And we'll talk more in detail about that as we go on. Is that okay? Because there's all sorts of mistakes people can make, some of which are easy for us to take care of, and some of which are hard. And so I'm going to teach you about the easy ones, and we're just going to pretend the hard ones don't exist for right now. Okay? Other questions? All right, I've been talking for 20 minutes. Let's have a 1-minute break. I'm going to turn the lights on because you all look groggy and stuff. They're going to fix this projector light, and then hopefully I don't have to turn out the lights all the time. All right, 1 minute. Okay, so the question was, even though we're on break, the question was, do I want you to use Nano for just this project, for all the projects? I don't care. I want you to use something that you're happy with. However, in the interest of not, like I said, breaking your will to live by giving you too much to learn all at once, Nano is like the simplest option. And as you program more and you get tired of using Nano because it's too simple, I will be happy to help you switch to something more complex. Or the TAs well. Or you can do whatever you want. If you are comfortable with the pace that you're going at and you want to learn a better editor, that's fine with me. Okay. All right. So we didn't really get a full break and nobody actually stood up. I'm going to actually start making you stand up eventually because I can see people, the longer you sit, the more towards horizontal you slouch down. Right there, I'm looking at you. So it's okay. It's my gauge of like how much of your attention I have. All right, so here's what, I'll turn this back out so you can go back to sleep now. All right, so here's what we worked with before. This was our flow chart on how to create, complete the projects, right? What's the first step? What's the first step? One more time, what's the first step? Why is it important to start early? Because you're gonna have time to get help if you start early. If you start too late, you won't have time to get help. And what will happen is the last night you'll end up pulling an all-nighter and it will suck. And how many of you all like it when things suck? Not many people. How many of you all like a comfort of ease and indolence and not having to work very hard? Me too. So if you start early, you're closer to this ideal lazy life where somebody will solve your problem for you once you realize it, okay? Which is good. First step is going to be reading the problem and designing the algorithm. Now, if you go to Blackboard, I have already posted the first programming project. It should show up now. The code, the algorithm design is due in 1 week from today, and the code is due the following week. Every semester I have a theme for the class. Last semester the theme was medical studies, epidemiological studies about heart disease. This semester we are working on refugee camp organizational and logistics software. So software that will support people who are running refugee camps. The first assignment is about determining how much water a refugee camp will need given the existing water supply, to determine if there's enough, and if so, how many additional refugees you can support, and if there's not enough, how many containers of water do you need to bring in to support the population that's there. So you can read through that and read it closely. The problem is actually in there, and the numbers, by the way, are not made up. The numbers for how much water people need are taken from, there's an organization called the Sphere Organization that sets minimum standards for humanitarian refugee camps, and there's a reference in there to their manual. So what you're actually working on is not a made up problem, it's a real thing people work on. So you're gonna look at that and design your algorithm. Once you have your algorithm, you'll go ahead and edit your code, compile, test, and so what we're gonna do right now is I'm gonna walk you through that process. And what we're gonna do is not solve the project, because I want you to do that, but we'll take a relatively simple problem and go through it, okay? So, what is a super simple problem that we can solve using the computer? Math. How about, what's the simplest math you can think of? Addition. How many numbers do you want to add? All right, so he wants to add 2 numbers together, which is actually perfect because that's what's in my notes. So, so I look like I'm being very responsive to you, but in fact, I'm just doing what I want to do anyway. All right, so the first thing we do is we know we have this problem where we want to add 2 numbers together, okay? So here's our algorithm. So what I'm going to do is I'm going to go to my editor. All right, now when I'm working in a slightly different editor than you'll be working on. This is something called Emacs. Nano is kind of like a simple editor. Nano I call is like the gateway drug to Emacs because almost all the little control things that show up at the bottom are similar to Emacs commands. In computer science, yeah, we won't talk about that now, but Emacs is a pretty commonly used editor. I've been using it for a long time. It's pretty powerful. All right, so the first thing we want to do now, if we go back to our flowchart, is we have our problem. What we want to do is add 2 numbers together. So what's the first thing we do? Start early. Read the problem. We've done those steps. What's next? Design an algorithm. So the question is, how do you design your algorithm? So here's how I tend to do it these days, and I'm just going to step you through it, is that I'm going to use what are called comments in my code to design the algorithm. So let me just save this as a as a CC file. Okay, so I have a CC file. Let me just see how big the typeface is. Make it bigger so you can see too. All right, is that big enough? Whoops, why is that not moving? Stop it. All right, there we go. All right, so here's what I'm going to do. I'm going to start by using comments. And the way that you use comments in C++ is if you put 2 slashes at the front of a line, it is a comment. Now, the idea of a comment is something that you can embed in your code that the computer, when it runs your algorithm, completely ignores. The computer will completely ignore any comment you have in there. So why do we have comments? Because people read your code too. And the idea of comments is that you can put notes in your code that when other people read it, will help them understand what you're doing. So here's how often when I'm programming for myself, what I do is when I sit down and design my algorithm, I do it all in the comments. I create an outline of my program in the comments, and then I go back and start writing code in. So here's what I'm going to do. I'm going to start, and when I say C++ comment, that is a comment that starts with these 2 slashes at the front of the line. There are other comments which I will show you in maybe in a minute. All right, so start with the C++ comment. So here's my program. So I have to add 2 numbers together, right? And what am I going to have to do to add these 2 numbers together? What is the first step of every algorithm? Start. Yep. Then what? Okay, so now one of the things if I'm going to do is I'm going to have to read the numbers, right? So I'm going to have to input a number, which implies what? Yes, sir. Exactly. Since we're working with a number, I'm going to have to say, so what I'm going to do is I'm going to put some space here to declare variables. Because in the C++ language, we have to be very explicit about what we're using memory for, and we have to declare it before we use it. So it's typical that we declare our variables early on in the program. Yes, sir? Yes, when I say declare, we can also, you can just assume that it's initialized. It's good practice. Here's the deal. You don't have to initialize variables. You don't have to, but it's a good programming practice, right? It's like the safe sex equivalent of programming, right? You just want to go ahead and use it just so you don't have to worry about it anymore. Now what's going to happen as time goes on in this class, I will forget to initialize variables sometimes, and you all can yell at me for it, and that's fine. Often when I don't initialize variables, it's because I know I'm just about to use them for input. Like most of the time that I don't initialize them is that if I'm just about to use them for input, I know they're going to be overwritten anyway, and I don't worry about it. But feel free to yell at me, because, yes? That means when you declare a variable, you put equals something after it. Okay, and we'll go into more detail about this. What I'm doing here is I've given you this one example, and I'm going to give you example and example, and we're going to do this over and over and over again. And each time we're going to add some language feature, and each time we're going to make our problem a little bit bigger. So we're going to do this again and again, because repetition is your friend in this, and you're going to have the opportunity to, of course, do it yourself too. Okay. Also, I haven't done it yet. But I'm going to be posting readings from the book so that you can read along in the book with us, and in some cases read ahead, okay? And you'll be able to see other examples in the book as well. The book is actually relatively short and terse. I kind of like it for that because it's like, here's just the stuff you need to know and not 50 pages of crazy things. Okay. All right, so here's our algorithm. We're going to be adding 2 numbers together. We'll start, we'll declare variables, we'll input a number, then what will we do? Okay, how many numbers are we adding together? How many have we entered? Anything else you think we need to do before we start adding away? We need to input another number. Okay, then what do we do? And I'm going to make my font a little bit smaller. So, can you all see? That's plenty big, isn't it? Can you read that? How about that? That? How's that? Okay. Say when. Bigger? Is that good? Make it just a bit bigger for me. Okay. Add them together. And then what do? We've added our numbers. We're going to do what? We're just going to output. Our algorithm doesn't call for any decisions. And what we're going to see over the semester is I'm going to be teaching you little pieces of things, and you're going to have to figure out, like given an algorithm, which of those pieces you use. We won't always use all the pieces. Okay? We won't always use all the pieces. And then after we add them together, we might want to output them. Output result. And then what do? Stop. Okay, so what I've just done is I have outlined my algorithm. And this is one way of doing it. This is when I am programming myself, this is exactly what I do. And if you ever look at my code, maybe not the code that I wrote for this class, but the code that I use for myself, it's full of comments that just have this outline format, because it helps me to outline things ahead of time. Great. So here we are. We have our algorithm started. What if we go back to the flow chart? That it's kind of hard to show you. Let's see. I wonder if I can show the whole thing and still switch. No. Okay. So here we are. We've read the problem, design our algorithm. What's the next step? Editing code. Now notice this editing code has edit, compile, check for errors, and go around several times. I'm going to encourage you, and I'm going to try to remember to do it in class, I'm going to encourage you to compile your code frequently as you go along. And the reason is if you sit down and you write out your entire algorithm and it's very long, and then you sit down and you type out all this C++ code and it's very long, and you try and compile it, how many errors do you think you're going to have in there? Many. You will likely have many errors. And how hard is it to fix like 20 errors at once? Well, you don't know yet, but I'll just tell you, it's like more than 20 times as hard as if you just have one error to fix. So what I'm going to do, and what I'm going to try and show you is, as I do this, I'm going to compile frequently just to make sure that there are no errors in what I'm doing. Because it's easier to fix one small error at a time than it is to fix like 20 errors at a time. Okay? Everybody with me on that? Sir? Absolutely. The compilation is the equivalent of your grammar checking. So essentially, imagine instead of highlighting things in that little red squiggle, is it red or green for grammar? Right? So instead of saying that you've done something wrong, you can just periodically check and make sure that your grammar is okay. So this is the grammar check right here, this loop. The actual check of whether it makes sense or not comes over there. So let's go ahead and demonstrate. All right, so here I am. I'm in my account on CS class, and now we're going to go back and do what we were doing before, which is I'm going to use the Emacs editor instead of Nano, and I'm going to Emacs this thing called add.cc. And in here, I need to quickly recreate the comments that we did before. Yeah, I'll do that. I'll go back and do that. I realized that was going on. Anytime we use things, we're going to have to actually declare the variables, so here we go. All right. Okay, so here we were. We were at start, and we said start was pound include IOStream using namespace standard, int main, open close parentheses, curly brackets, and then stop was what? Return 0, and close the curly bracket. All right, so you'll notice that my editor, because I'm using Emacs, changes the color of things. That kind of helps figure out what's going on sometime. So this is one of the advantages if you want to make the effort to learn a better editor as you go along. This is work for it. So now what we're going to do is I'm just going to pause for a second. I'm going to compile and make sure that this compiles correctly. Okay, all I've done is put the stop and start in, and it compiles correctly. When I run the compiler, where does my program appear? Anybody know? So I did g++ add.cc. Where did my program go? Yes? Nope. That's a good guess, though. Here. Anybody else? ls, though, means a list subdirectory. It will show you all the files that are there. So if we type ls, we can see a certain thing. We can see there's add.cc. We can see there's an add.cc tilde, which is like a little backup file created by my editor. there's this thing called a.out. By default, when you compile something, it will appear in a.out. Now, if you don't want it to appear in a.out, what you can do is you can add this -o, and when you do that, add.cc-o, that means when you output the compiled program, which is the executable program the computer can run, put it in the file named add. And if we do ls again, you can now see there's this thing called add. Hang on a second, see if I can move that over a little. You can see there's this thing that, my thing puts a star after that and means it's a program. Yes, sir? Yep, that's it right there. Add.cc is the CC file, and then add is the compiled program, and it also happens a.out is the compiled program. I made 2 different versions of it. How do I run this? If I want to test it, /add, and it ran and it did nothing. Is that good or bad? It's good, right? Because the only program we put in there, the only thing we put in there so far is the program that does nothing. Did this do nothing? We are successful so far. And we are happy when we're successful, right? So if I go back to my editor now, I can start doing some other stuff. So I need to declare some variables. Let me ask you a question. What type of numbers do you want to add? Do you want to add integers, floating point numbers? Floating point? All right, let's get pretty risky and out there. Okay, so we're going to say float. And we're going to say, what name do you want? What? Number 1, which is going to be our name. And do we want to initialize this? Yes, the answer is always going to be yes when I answer that question. And it's common when you do a float point number just to put a decimal point in there. It is not necessary to put the decimal point in there, but it lets other people who are reading your code easily figure out that that's going to be a decimal number, right? It reinforces that for people. And so we might want another number. We'll call this number 2. And we'll also initialize this 0.0. All right, so we've done this. What should we do now? Compile. I probably wouldn't compile here because I'm pretty confident that's right, but it never hurts to jump back and just say, oh, I compiled and there's no errors. So what might happen here is if I did something like I forgot a semicolon and I compiled it, I would say, hey, you have an error, and there's only one error to fix. Okay? So what I just did there is I purposely inserted an error. Every line in C++ ends in a semicolon. So I took the semicolon away, and the computer went, hey, you had this line that didn't end. Yes, sir? All right, so remember when we declare a variable, which we'll do in more detail, it has a type and a name. Float is what is a basic type for decimal numbers, whereas int is for whole numbers. And it has to do with how those numbers are interpreted. Okay? And we'll see some more of that going on. So, other questions? Everybody good so far? How many of y'all are good? All right. So, now we have declared the variables that we can use. Do we need any other variables? No? All right. Well, if we need to, if as we go on we need some other number, we just come back here and put it in there, right? As we're going along if we need to. So we're going to input a number. How do we input? All right. So we're going to input a number. Now what do we do? Let's stop and compile for a second. All right? How many of y'all want to stop and compile? You don't have to do it every single line, but doing it every so often. So we'll compile. Our program compiles. You curious what happens if we run it now? Anybody curious? So let's go ahead and run it. And the way we run it is just /add. And so we do this, and the program just seems to sit there. Why is it sitting there? It's waiting for input, right? How do you know that? Because you just saw us writing it or doing it collaboratively, you just saw it. How would somebody who is running your program know what to do? Yeah. Yeah, they don't know. Like right now, somebody ran your program, they'd be like, well, it's not doing anything. What do I do? What we need to do when we do input is to make sure that we tell the user what we're expecting. Okay? So how do we tell the user what we're expecting? Cout, angle, oops, wrong brackets. So I use the cout. Please enter a floating point number. Enter the number. Now notice that this is something that just came up like while we were going along, right? I didn't have to put in a comment saying that we're going to enter a number. We can just include this all as part of the step of entering numbers. Okay. Does that make sense? Everybody with me? Questions? Great. So now we have to input another number. Sorry, I'm just going to line the comments with the code. So what do we do to input another number? Yep, cout what? And then what? Now, by the way, I hear a lot of click-clack typing in here. I'm going to upload all the code examples I do in class to Blackboard, so you can just download them and play with them. You don't have to necessarily worry about capturing them in class if you don't want to. Okay? It normally takes me I normally do it right when I get back to my office and eat lunch. Sometimes if I forget, you can email me and remind me. All right, so we've completed a few steps of our algorithm. We've declared variables, input a couple of numbers. Do we want to stop and see if this is working? So we'll compile quickly. Compilation went well. You know compiling works if it doesn't give you any error messages. Remember, like the first day of class, I talked about the compiler and I told you it was a rude piece of software? Remember that? I said the compiler is rude. This is how rude it is. If you do everything right, it won't even talk to you. It only exists to yell at you if you do something wrong. Okay? Yes, sir? So we can make any number of mistakes in our program, and I'll tell you, why don't you ask that after we're done, and I'll go back and I'll show you some of the common ones. How's that? Okay. All right, everybody good so far? All right, so we'll go back to the editor, and now we have to add some numbers. How do we add numbers? Any guesses? The plus sign. So if we do number 1 plus number 2, there we go. We have added numbers. Yes, sir. You have a question back there? So the question is, do we have to store that value in another variable? If you want the computer to remember it, you must explicitly store that value in another variable. Okay? Now, here, let me just tell you what this does. This line of code that says number 1 plus number 2, here is what this does. The computer sees this and it goes, number 1. Where have I heard that before? And it goes, oh, somebody declared it up there, and now it has a value in it because somebody put input. So I know there's a box somewhere named number 1 that has a number in it. And I know there's a box somewhere named number 2 that has a number in it. I will add those together. And it adds them together. And then what does it do with the result? Nothing. It does nothing with the result. It will immediately go on to the next line of code, which in this case is return 0, without even ever thinking about that again. It will happily add those things together and do nothing with them because that is what you told them. Now, one of the cool things about C++, it's descended from the C language. The assumption in C and C++ is that the programmer always knows what they're doing. And the computer will blindly go along doing whatever you tell it, trusting that you know what you're doing. Okay? Which is nice because it lets you do very powerful things, but it's also dangerous because it lets you do very wrong things sometimes. Okay? Different languages have a different philosophy. This one says the programmer is always right, and even if you're wrong, you're right. So this will add two numbers together and do absolutely nothing with them. All right? So what do we want to do with those numbers? Store them somewhere. Where are we going to store them? Another variable. Did we declare any other variables? We did not. So let's go back up to the top. There's no harm in going back later and declare a variable. What are we going to call this one? Let's call it sum, yeah. Do we need to initialize this? Not really, but we always will, right? The answer is always yes. Yes, sir. So we could do it this way. We could do something like this. That is legal. I will encourage you to not necessarily do it that way. And here's why. This is a very small program, and it's easy for us to see what's going on right here. In large programs, if you do inline declaration, which is this is called, it can be very difficult when you're reading code. You come across a variable and you go, oh, where was that created? Then you have to like scan back through the code to find the right place for that. If you just always initialize your variables in a block at the top, which is often a very common programming practice, everybody knows where to look for a variable. So when you say sum, you go, oh, I don't know what sum is. Where do I look? Well, I just go, I know all my variables are declared at the top, so I can just go look up there. Okay? This comes down to a matter of style, and there's different programming styles. Okay, everybody good so far? So now we've declared this additional thing, and we are storing the result in sum. Now we have output. How do we output? Cout, angle, angle, and we say the sum is, and then you just say sum, and we'll put the end of line there to go on to the next line. We'll see more about this. This will output the sum is, and then it'll figure out what is stored in this box named sum, which should be the addition of those two numbers, and then output that. How are we doing? Everybody good? So let's just take a quick break, and we'll compile it and see if it compiles. Good news, it compiled cleanly. Here, I'll put that up at the top of the screen where it's easy to see. Right, we compiled, and it compiled cleanly, and we are, when things compile cleanly, you are happy. Yes, people are happy when their code compiles cleanly. So now we have to test it. How do we test it? And let me just tell you, let's just check really fast. So here is our program. Have we implemented each step along the way of our algorithm? Declare variables, input number, another number, add numbers, output, stop. Yes, so we seem to have completed our algorithm. If we go back and we look at this flow chart, whoops. If we look at this flow chart we have here, oh, that seems bad. Where did that go? Okay, where did all my other stuff go? So this is what you get for upgrading between operating systems, and not teaching the class on it. So, all right, let's not look at the flowchart because it apparently has gone off into it got swamped under that giant wave or something. But the next step was to test our code, okay? And here's what we're going to do. We're going to test our code by running it and seeing if it does what we expect. So, who has a floating point number for me? 4.2. Who has another number? 7,004. Oh, 7,004.2. Sorry, let me do that again. 4.2, 7,004.2. Any guesses on what this is going to be? Okay, so does our program seem to be working? Okay, now in this program, this is a pretty small program, right? So we can look at it and get a sense if it's working or not. For other larger programs, it is important to use a variety of test cases, okay? It is important to use a variety of test cases. And you need to be responsible for testing your code and thinking about the places that it might go wrong, right? So, so we'll see some more of that as we go along, but testing your code is important. In fact, there is a school of programming when you write your program. Before you write your program, before you design your algorithm, you write your test cases. So when people do software engineering and they're building a big system, they say, okay, I'm going to build this thing, and I have an algorithm, and here's what I know about my algorithm, is that when I input this, I expect this output. When I input this, I expect that output. And they will sit down and write all the test cases for their code first so that they know if their code is working. And then as they develop their code, each time they develop it, we're running it here just to see if it works. They will actually run it against their test cases and see which test cases it passes and fails. Does that make sense? So part of the code definition and the algorithm definition is the creation of test cases and to make sure they work against them. That is something you'll probably see later in the curriculum. We're not going to do it for this class, but it's very common practice. All right. Everybody kind of understand that? If you work out your test cases ahead of time, then you have something to automatically test your code against. All right. So I think we're most of the way through that flow chart, aren't we? Right? What would we do now if this was our submission? Yep, we would submit it and download it. Oddly enough, on this computer, I don't have the download software installed, I don't think. So I can't easily demonstrate that for you, but it's in video for you. So, all right. So what we just did, what we went through, is essentially what you need to do for your homework assignment, which is now due tomorrow. You need to just type in the program that outputs your name and net ID. It's pretty easy. Your whole algorithm is start, print out your name and net ID, stop. Doesn't get much simpler than that. And then compile it, make sure it works, and then upload it to Blackboard. The purpose of this is that the mechanics of doing this are somewhat cumbersome on occasion, and I want you to practice just with not having to do the algorithm or coding, so that the next project that you do, which will be much larger, you will already have those basic mechanics at least understood, right? Does that make sense? So you don't have to do it all at once. All right, so there's our simple program. Any questions? Yes, sir. Yeah. Thank you for the reminder. So the question is, what kind of things go on here? Well, we could do something like, use an incorrect operator. So here, what I did is I changed the double bracket to a bracket, right? This is like a typo, and if I compile it now, it will give me an error. The error, and let me put that back up at the top of the screen so you can see it more easily. Sorry. So you get an error, and it says in this case, no match for operator angle. And here's the thing, it says, okay, in order to find the error, it almost always tells you a line number, and that gives you a clue as to where to look. The error is not always exactly on that line. Sometimes the line before has an error that doesn't get caught until the next line, but that gives you an idea to where to look. So if we go back here, in my compiler right here, this thing L19 shows me what line I'm on. So I know I'm on line 19, and I can see, I say, oh, I forgot that. I forgot the double angle bracket. If I take a semicolon off, and try and compile it, it will tell me I'm missing the semicolon, right? If I put that back, say I take out the pound include IO stream, this one might be crazy. It says it no longer knows about cout, cin, or nline, because that pound include IO stream is actually a library that other people have written that allow us to do input and output. Remember I said that we use libraries? That's actually a library. So if you're missing the library, you might get errors like that. So anyway, those are all sorts of different things that might happen. Yes? All right, so I'm cheating here, and I'm cheating because I'm doing it in class, and I only have room for one window. And it's easier for me to use one window to switch back and forth. But here's what I'm doing. I'm in my editor, when I'm using Emacs, I hit Control-Z, and Control-Z suspends my editor. See how it says suspended right there? And I can do other stuff. And then when I type FG, it unsuspends it. This is stuff I don't expect you to know. I would really just suggest you open two windows. But I'm doing it a little bit differently because I only have so much space on the screen. Sir? Okay, so the question is, what happens if you're asking the user for a floating point and you give an integer? What happens if an integer and a floating point? We'll talk about that later. Okay, I guarantee you. So, do you have a question too? That was someone. Okay, so we'll talk more. We're going to go into more detail about all this stuff later. Trust me, we're going to go into much more detail about all these things as we go along. All right. Other questions? Yes? Okay, so I mean, I'll show you what the idea is between nline. So notice what I did right here. I used nline because let's take it out and see what happens. How's that? Here's the nice things about this is that there is nothing you can unless you try really hard and look it up on the internet. There's not much you can do inside your program that will hurt your computer. Right? There's no magic thing that if you type is going to erase your hard drive and lose all your work from other classes. So just feel free to like mess around with it and see what it does. So the question is for nline, what happens here? So I took the nline away from the last output, and if I compile it, try and do this up to at the top of the screen. If I compile it and then I run it, it says enter a floating point number 3.1414. And you can see it came up with a sum, but now look, the prompt, like the next line, is all mashed up in there. Because what inline does, it says after you print it out, go down to the next line. And what happened is it didn't go down to the next line because it just ended right there. So it printed out. So if I put this inline back, and we do this again, right? I'll clear the screen to put things up at the top, compile it, I'll run add 3.2, 7.1. Now notice that it pushed it down to the next line. So the inline, which we'll talk about later, is anybody, this is like antique tech, anybody ever seen a typewriter? A few of you. Someday I'm going to raise my, people are going to be like, no. And that's the day I retire, right? So just tell that to the next class if you want me to retire, not to raise your hand. So you're like typing along, and the inline is like says, next thing I type will start on the next line. Does that make sense? It says go to the next line for things I start. So I didn't put inline up here on the input, right? Notice there's no inline there. Y'all see where the cursor is? Because if I put an inline here, like this, then when I compile the program and run it, what will happen is it says please enter a floating point number, and now it's like on the next line, which is fine, right? It's just it looks neater if you're actually entering the floating point number. So it's just a matter of how to format your output. Does that make sense? You asked the question, right? Oh, sorry, you asked the question. Sorry. So does that make sense? Does that help you? Okay. Yes, sir.
So for our homework, we just have to write a program that when you run it, spits out our name and net ID, or do we have to say please enter name?
Your program only has to output your name and net ID. So it's going to have, I mean, you want me to do my program that does that right now for you all, so you can see it? There's one output statement. So here's we do, pound, this is about how fast you will be able to do it eventually, pound include IOStream, and by eventually I mean after you've been teaching a class like this forever. See? I don't know what you're talking about. Using namespace. Now you messed me up. Standard. Okay. ISOTream. ISOTream sounds pretty good too. IOStream. Int main. Return 0. By the way, anybody have a fear of public speaking? Anybody not like public speaking? You should try public typing. It's really hard. Cout, angle, clay, shields, clay. Handle. All right. I compile that. I clear. Let's just run it and see what it does. I'm done with the assignment. Yes, sir.
Does it matter if we don't use the end line at the end of it for homework one?
Yeah, you should use the end line. You should. You should. Yes. No. We're going to talk about that later. So, okay. Everybody's interested now. What happens when you put like whole numbers into floating point and floating point into whole numbers and stuff like that, right? Aren't you? Yeah, we'll get to that. Relax. What? You can read it too. So we'll see what happens. We'll get to that. Okay. All right. Other questions? Do you feel comfortable that you're going to be able to do the assignment by tomorrow night? I am. I'm comfortable you can do it. So it doesn't matter what you think. Okay. Other questions? No. All right. So that's the intro stuff. I'm going to start just showing you other things that we'll need to know as we go along, because we have 10 minutes left, so why not? Anybody curious how I got the name, the net ID Clay? Anybody have a cool net ID that's her first name? No? I do. All right. Where was I? All right, so here we are. We're editing our file here. Let me show you some other stuff. So one of the things that it's common to do is at the top of your program to put in a header in the source code so that people who are reading your code will understand what it does. Okay? So one of the ways we might do this is say something like this program adds 2 numbers. We can say the author is Clay, stuff like that, right? So we have at the top a little block of information so that when people start reading your code, they have some idea of what it is. So C++ comments, every comment in C++ starts with a double slash. And it is your way of leaving notes for other programmers. Now, we know that C++ is a language, right? A computer language. Did we talk about the origins of C++? Did I talk about it? So, how many of you all have ever spoken Spanish, French, Italian, Portuguese? Anybody in this class? Some of that? Spanish, French? All right. What language are all those languages descended from? Latin. So C++ is, in an analogy, a language like Spanish, Portuguese, French. Did I forget French? Right? Italian, one of those languages. It is based on a language named C. C, right? It's based on a language named C. C is a language that's been around forever. It's one of the proto-languages that crawled out of the early slime of computing days, but it's kind of like a cockroach. C is the cockroach of languages. C language will be around longer than we will live. People will still be programming in C when I die, when you die, when your children die. All right? C will just be around forever. I'm convinced of that. Like a cockroach, it will survive the end of the world. All right? We're using C++, which is an extension of C, and we'll see a little bit later in the semester, we'll see why it's called that, and we'll learn a little bit about why it's different. But one of the things we're going to find as we go on through the semester is that because C++ is descended from the C language, there are things that are leftovers from C that still show up. Now, I'm going to refer to these kind of like irregular verbs. You all know the concept of irregular verbs, right? There are going to be some things that will be along and be like, oh, now we have to do this weird thing because it's C and we have to do it the C way, okay? So one of the things that's left over from C is a way of doing comments. And the way you can do comments in C is just like this. You do a /* and a */. And anything in between that has a star in the beginning, like that, is what's called a C-style comment. And then if I wanted to do the same thing, I could say, you know, this adds numbers, and I could say that I'm the author. Both of these do the same things. Both of these do exactly the same things. All right? A C-style comment starts with a slash and a star, ends with a star and a slash. A C++ comment is just 2 slashes, and it goes from there to the end of the line. All right? And these are ways that you leave notes for other programmers. Now, one of the other things you can do with either one of these is you can have comments at the end of the line. Okay? So we can put something after our variable, which is an indication of what that variable is for other programmers. And we can put it just at the end of the line. I would caution you, I almost never write comments that way. Almost never. My preference is just to put them on a separate line before. Like that, right? I would say something like that. But you can have, you know, end line comments. You can also have them in C style. Just like that. Both of those are valid. Okay. Yes, sir.
So write a C++ style comment.
Mm-hmm.
And don't start a new line. Everything of that, like the code won't run.
So, I mean, so I'm not quite sure I understand your question. So C++, yeah, if we take out, yeah, if we took, we're never going to do that though. All right, so let me tell you one other thing in this class. You're going to ask me questions and you're going to say, is it possible to do this? And you know what my answer is almost always going to be? Yes, I'm always going to say yes. The computer language is just a way for you to do and force the computer what you want to do. I can tell you for almost anything you think of, there is a way to do it. All right? And when you ask me, hey, can you do this? Often I will say yes. And that's almost going to be always followed by one word, which is but. I'm going to say yes, but you almost never want to do that. So he asked me if we took all the spaces out of this, if using a C++ comment would screw things up. It would. But it's not ever going to be a problem because we're never going to take the spaces out. And why are we never going to take the spaces out? Because we want other people to be able to read our code. Okay. Yeah, anyway, there's something, if you're really curious, over the next couple of days, you can look up. It's called the International Obfuscated C Code Competition. And what people do is they write programs in C or C++, and the whole goal is to make your program as unreadable to humans as possible, but have it do something that's really cool. And if you're interested, you can go look up IOCC on the internet, and you can find all these crazy C programs. And now that you know how to compile them, you'll actually be able to compile them and run them. And it's, let me just say, you can do horrible, horrible things with the C and C++ languages. And so don't do that, okay? Be kind to people who have to read your code. All right, so comments. That's probably enough for today. What do y'all think? All right, so we're kind of a day behind. Let me just tell you quickly. I'll just show you. I did try to make the first project a little bit simpler because we're a lecture behind, but you can run it just by doing this, right? My screen's not big enough. So you're going to have to test your code, but you can run it if you want using my code. 12,570 refugees. We need about 9.3 liters a day. There are 5 working taps in the camp, no pumps, no wells, and we're short by 98,901 liters a day. We're going to have to bring in 66 M149 400-gallon water buffaloes a day to make sure people get water. This is the program you're writing. Okay. So you can when you're writing yours, you can run mine to see how yours should work if you have any questions. And there's instructions on the webpage how to do that. Yes, sir. Yep. Yeah. Okay, so there's 2 sections for this class. We are section 2. Section 1's professor cares about how you name your assignment. I actually don't care. So if you just, I don't know. Do you want me to care? Would it be easier for you if I cared and told you what to do? So, I don't think so either. Because what ends up happening is when you upload it to Blackboard, Blackboard renames it anyway. And so when we download it out of Blackboard, it has your net ID on it. It's a big, ugly thing, but I don't care about big, ugly things. So, all right. Enjoy your long weekend. Hopefully we will not get snowed out again and can continue working on next week. Anybody need a caramel before you go? Yeah, if you do something else, you should always go and compile it on CS class to make sure, because there's differences between the compilers. And what will happen is when the TAs go to test it, they will use the CS class compiler, and you're going to get hosed on your grade. Yep.